Good morning, everyone. So I hope I am audible. Shirish, am I audible? Shirish, Eldo,
Yes, sir.
fine, fine, fine. Thank you for confirming. Okay, I think you have seen the posts that I have put on the Google Classroom. Okay, we will be having our intervals on 13th and 14th. Okay, so most probably, yeah, ours might come on 14th. Okay, by then we will try to finish 1.5 modules. Okay, first module I have posted the notes. Okay, and accordingly we will try and have some discussions. Okay, fine. So if you can remember, what was the last thing that we discussed previously? Maybe one of you can tell me what was the last thing that we discussed previously in the last class. Did we discuss about delays, the representation, right? Okay. So yeah, so today what we will do is we will continue the session, and we will try and discuss as to how these are very much implemented, okay, when we consider these gates, and how to overcome these, okay, or what are the methods in which these gates can be described, and how do we describe it, okay. So all this we'll discuss in today's class. Okay, so just wait for a moment. The presentation will be right up. Okay, so I hope you are able to see the presentation. Right. So here what did we discuss? When we give assign hash to d is equal to a and b. Okay. Um, say for example there is a time delay of 5 nanoseconds, so that is going to get added here. So after 7 nanoseconds we will get the result, right? That is what we had discussed. So this is nothing but called your delta delay. Okay, and this is your general format: assign delay signal name expression. So we have seen this in the last class, right? These are some of the correct names and the wrong names examples, right? So today we will be discussing about the vectors. Now what do you understand by vector? For example, if I have to say 3 down to 0, in VHDL we use 3 down to 0, okay, but here we do use 3 is to 0. So this means 0 1 2 3, 3 bits, 4 bits, okay, 0 to 3, 4 bits. Okay, so this has the range 0 to 3, and the elements are b0, b1, b2, b3. Now let us take one example. If there is a statement, okay, this is nothing but 4 tick. 4 tick means 4 bits, okay, 4 bits, and the format is binary. B means binary, okay, and these are the values 1110. Okay, so 1 is given to b3. This is like this: b0, b0, b1, b2, b3. Okay, so this is how the assignment happens. So the lower significant bit, lsb, okay, is given to b0, then b1, b2, b3. This is the most significant bit. Okay, so this is how your vectors are defined, and we use 3 is to 0 and in square brackets. Now let us take this example. Okay, so we see that a b 3 is nothing but 3 bits, okay, 3 inputs, c, then a b c, a b c. Okay, so here the 0th bit, okay, first bit, second bit, third bit. Okay, so this is the way to actually understand how it works. Now, suppose you want to actually go into the hard way of programming, which means how it is exactly programmed. C3 is equal to A3 and B3. Okay, so here you can see C3 is actually A3 and B3. In simple, if you don't want to use 0, 1, 2, 3 bits, okay, what you can do, the most easiest way is C is equal to A and B. So when I use C, it is taken as common 0, 1, 2, 3, or everything is taken in general. Then A is also taken as general, A0, A1, A2, A3. It's taken in general. B is also taken as general, B0, B1, B2, B3. So C is equal to A and B. This becomes the most simplest form. Okay, so double and, okay, ampersand is nothing but your logical AND operation, and the single AND is nothing but your bitwise AND operation. Now there is something called Verilog modules. Okay, we say module, module name, and whatever is the parameters, inputs and outputs, inputs comma outputs. Okay, so let us take a simple block here. I might ask you a question. A module is a dash that declares input and output signals and simplifies the internal operation of module. And by the way, keep in mind, for our internal point of view, we will be using uh, you know multiple choice questions. Okay, MCQs will be the pattern for your internal point of view. Okay, so I will be using the notes that I have shared with you. I'll be using these notes, and also you can refer the textbook that is being provided. I have given in the start of the session as to which textbook that you can refer. So those textbooks will be used in order to frame questions for your internals, right? Okay. So one of the questions can be, okay, example, um, a module is a dash that declares input and output signals and specifies internal operation of the module. So you can say a module is a basic building block, or the question can also be like this: what, or a dash is a basic building block that declares input and output signals. So your answer should be module. Okay, so here this is one such block, okay, where you have inputs A, B, and output as C, another input as D, and output as E. Now here we have two different types of gates. One is the AND gate and the OR gate. Okay, so the OR gate's output is actually dependent on the input of AND gate. So only when this AND gate gives us output C, then that is taken along with B and it's computed. Okay, so how do we write it? Module, two gates, A B C, A B D E. Okay, A B D E. We are only writing inputs and outputs. We are not writing intermediate. Here C is what? Intermediate, which is lying between gate and gate OR. Okay, so this one is declared as wire. Something which comes in between two gates, we take it as wire. So what is the equation now? C is equal to A and B. This is done. Next, E is equal to C or D, end module. So this is your simple program. Okay, I might even give a program. Okay, and I might make some errors in the program, and I might tell you what is the error. I might ask you to check what is the error, right? So accordingly you can actually build your program. So that can be one of the questions. So here C is an internal signal, so it has to be declared as what? Wire. So keep that in mind. Now, module. What is a module? Module is nothing but I can have a single module or I can have interconnected modules. So this modules can go from 1 to n. So which means I just cannot have one single module, module 2 gates. So this is just one module. So like this, I can have many other modules. Okay. So that is what I am trying to say here. Okay, so module 1 can be connected to module 2. So like this you can have many modules interconnected. So this is the general form of a module, module's name, and whatever is the connecting uh, parameters, inputs comma outputs. Okay, most generally that is used. Okay, so keep seeing this, and maybe if you wish to, you can make note of this. So this is how modules are connected one after the other. Any doubts here you can ask, or we can proceed. So here are both declarations, function specification. Okay, what is functional specification? This one, assign statements. Okay, so that's your functional specifications, and then end module. Okay, now go through this program here, the next program. So here what is happening in this program? So in this program we see we have module gates A, B, C, D, E. Okay, so there are two different types of programs here. Inputs can be A, B, C, output can be D, E. Okay, so for D I have A or B, and for E I have C or D. So however is your uh, you know circuit, so accordingly you can actually build your code. Okay, so here the thing that you have to understand is statement 2 uses D as an input. Okay, statement 2 uses D as an input, but here it is actually an output in statement 1. So in statement 1 it is an output, and in statement 2 it is acting as an input. So you can declare it in output and use it, no problem. So here what we can also do is, um, instead of using only for output, you can use in out. The reason why we are using in out is because it is used for output as well as input. So in out, so what I will do, as usual, I will write module gates and all these parameters, then inputs are A, B, C, output is E. In out, this is a new term now. In out is nothing but input plus output. Okay, so these are taken into consideration. Next, the same assignment statement can be given. Assign 5 after 5 nanoseconds. D is equal to equation, E is equal to this equation. So this becomes more clear actually when you write in out. Okay, so that is what is given here. Just go through. So in VHDL, the naming is very strict. Okay, if you have given it as input, you cannot use it as output. But in Verilog, it is not that case. Okay, uh, it can produce an output even when the variable is declared as input. Even though you have written it as input, you can even use it as output. So that is the level of flexibility that you have in your Verilog. Okay. However, a variable has to be declared in out if that variable is to be used by other modules. Now there is a catch here. Now in the local program, in the same program, if you want to use it either as input or output, that's fine. But if in case you want to use this parameter d in somewhere else, in some other module or in some other program, then this should be declared as inout. You cannot declare it as output and use it as input in some other module. Okay, so that's a must. So take this as an example. This is a very well known circuit to all of you, right? So this is a full ladder where you have XOR function, AND function, OR function, right? So for sum you have X XORed with Y, XORed with C in. So that becomes your sum, and carry is XY plus XC plus YC, right? So module name, all the parameters, outputs. What are outputs here? Sum and carry. Inputs are X, Y, and C in, and then accordingly you will have assign the statements in the module. Okay, so I hope you are clear in writing a program for this. Now let us actually build it. Okay, instead of having just one section, we will try to have four smaller modules here, and we will see how the code is going to look as. Okay, so here you can have adder of 4-bit. Okay, a naught, b naught, giving you s naught, s1, s2 up till s3. Okay, so a and b gets added, and then you have a carry and then sum. So carry sum, carry sum. So that's how this works. So I will be naming it as adder 4 sum carry a b c I. Then output will be 3 is to 0. So what is this 3 is to 0? It means that it is going to be 4-bit, 0 1 2 3, 4-bit. And what is it? It is s. So which means s0, s1, s2, s3, right? Your output is going to be c0, c0 or c4. Input is going to be 3 is to 0. Okay, what is this 3 is to 0 for a and b? A0 till a3, b0 till b3, and then your input, your ci or c0 is your input. Okay, now c is used intermediately here, so I use it as a wire, which is c. It's an signal, internal signal. So how do I now use this full ladder fa0? So I use this. Okay, first the inputs a0 b0 comma ci. Ci is nothing but your input, comma then your output. So inputs comma outputs, so that is going to be your format for declaration. Okay, instantiation. Next in full ladder 1, this is full ladder 1, a1 b1. Okay, c1 is your inputs, then c2 and s1. Now here you can even swap c2 and s1, that's fine, but you cannot put output in the input side. Okay, so that nomenclature you have to follow. Inputs and outputs are to be separated. So the same thing happens for the second full adder 2, and then full adder 3. So this is how you write your code. So this is nothing but called port map. Okay, port map, uh, where we try to instantiate each particular block. Since we are using a proper positioning of inputs and outputs, we call it as positional association. Okay, so what is positional association? I cannot change the input and the output, which means I cannot interchange them, inputs comma output. So that should be the nomenclature. Okay, that should be the rule. If the ports are mapped by name, then it is called as named association. So here we are using a0 b0. Okay, so the positions are, it has its own position, so we use the term positional association. Okay, Now we will see something called Verilog assignments. Verilog assignments are of major two types: continuous, procedural. So now in continuous assignment, we have a keyword called assign. So whenever I have a keyword assign, then it is called continuous assignment. Whenever I have a keyword initial, always, then that is called procedural. So these two comes under Verilog assignments. Okay. So again we have two different bifurcations here, which is your for continuous, which is explicit and implicit, and here again for procedural we have two: blocking and non-blocking. Okay. So this is a very important diagram, okay, where you will see differentiations between the types of assignments. Okay, continuous, procedural, explicit, implicit, blocking, non-blocking. Okay, all these are very much important. So two important things: continuous and procedural. So continuous will have explicit and implicit, procedural will have blocking and non-blocking, initial, always. So these are the keywords. So I can ask for your test as to, assign is used for which one, initial is used for which type of assignment. Okay. So these are the explanations as to where we are going to use them. How is continuous assignment, how is procedural assignment. So here you will be able to understand whenever there is an equal to. Okay. It's a continuous assignment. How do I call it explicit? Okay, C is equal to A or B. Okay. Implicit, wire. Okay, wire D is equal to E and F. Okay, I am assigning. So whenever I'm using an assign, becomes an explicit continuous assignment. So this is driving nets. Okay, and left hand side is of net data type, and we use the keyword assign. So whenever there is an assign, it's a continuous assignment. And I will not be using this in initial and always blocks. So here in procedural there is no assign keyword. Okay. uh, and excuse me, and it is located in initial and always statements. So we will see them. Okay, in detail we will see them as to how uh, we will try and explain as to what is procedural and what is your continuous assignment. Okay. So just go through this PPT. So here in your procedural assignment, okay, so we will see one by one as to what exactly happens here. So combinational logic constantly reacts to input changes. So if you have a combinational circuit, what's a combinational circuit? You will have, just like we saw previously. Okay, take this as example. Yeah, so we can call this as a combinational circuit. So suppose whenever there is a change in x, y values, what is going to happen? The computations are going to happen differently. So which means there is a constant monitoring of x, y, and c in. Okay, so that is meant by your combinational logic constantly reacts to changes in inputs. Okay. Whereas synchronous or sequential logic responds to changes that are dependent on clock. So in sequential circuits, it is just like serial circuits. Okay, it is not dependent on the combination of inputs. Therefore, the procedural assignments are used to model sequential logic such as registers and FSMs. I think FSM you would have done in your digital electronic circuits, right? Mealy and Moore type of models. So there, you will be seeing exclusively as to how to represent the data, what is the input, output, and how accordingly we model them. Now, unlike the continuous assignments uh, with procedural assignments, now what is continuous assignment? We will use something called assign, and then we use equal to symbol. So unlike continuous assignments, with procedural assignments, the execution of statements happen with a sequence of operations. So it is dependent on a sequence. So it's called a procedural. There are two types, which is initial always we have seen. Okay. So now we will see what is initial, what is always, and how we use them. So see this slide, and you will be able to understand exactly what we are talking about. One more thing I wanted to ask you all. Will it be fine if we have a class at 2 o'clock, Saturday's class? Yeah, Saturday's class, three classes we are to make up, right? So, can we have it at 2, 2 to 3? 1 hour we can schedule.
Okay, sir.
1 hour we will schedule. Um, if not, if you have any other classes, you guys, in that period, 2 to 3, all of you. Any other thing is there in that particular time frame?
So 2 to 3 we have to check, sir.
Wait, I will check the timetable. This Monday, 2 to 3 is 46. 46 Arvinda sir's class. Anybody of you have registered to Arvinda sir's class? LIC, Linear Integrated Circuits?
No, sir.
No? Anybody in the group? Anybody in the group? We can accordingly we can plan out, that's fine. Okay, anyway, we will finish this class now. Okay, we'll finish this class, and accordingly you guys can check out your schedule. 2 to 3 will be probable. Okay, if possible we can even have 2 to 4. Okay, 2 to 4 is also fine, so the two of Saturday's classes we can make up, and another class maybe, somewhere we'll have to try to make it up, because your internals are coming and I want to brush up all these concepts so that you will be more comfortable for your internals. That's my point. Okay, fine. So we will decide. We'll finish this class, and then you guys can decide, and then we'll think on it. Okay, fine. So now look at this presentation here, and you will be able to see as to how we are using initial and how we are using always. So just have a look. We have the rules at the top, okay, and then we have the template at the middle, and we have a code. Okay, so just have a look at it. So here in this subject, the most important thing that you will have to remember is the rules. rules of coding, when, how I'm going to use initial, how am I going to use always, what is the template. So these things are important to be remembered. Okay, so now in under initial, you will find that it executes only once, so which means it is not a continuous loop. But wherein in always it is a continuous loop. So once it starts, okay, once it starts, it can actually go on and on. But in initial it just starts and ends. So that is one important thing that you have to remember. So initial doesn't have a loop, always has a loop. Okay, it's easy to remember, right? Always loop, initial no loop, executes without waiting. So there is no waiting time here, it just immediately starts executing. Okay, but then in always, there is an event. Okay, it waits for an event and then it starts executing. Here initial, it is useful when we are actually looking for only simulation and verification, but here it is useful for synthesis. Now remember, in my previous class I had mentioned about synthesis. What is synthesis? It is relating to your clock, the information with regards to rise time, fall time, and all those things, right? Okay. So initial, begin, then your sequential statements end. But here for always it is a loop. As I told you, it's a loop. You have begin, here also you have sequential statements. At is used here. Now that is important. Initial at we don't use, here we use at. Okay, so this becomes your sensitivity list. Whatever is in the bracket, it becomes sensitive. Whatever changes in those parameters inside the bracket, immediately it is tracked and again it is executed as a loop. Okay, so that one you should keep in mind. Now let us see a code always at ABD. So ABD is your sensitivity list. C is equal to A and B. Okay, logical AND operation, and C is equal to C or D. So here blocking operator is used. What is this blocking? Equal to statements execute sequentially. So one by one the statements execute. Now let us see here non-blocking. When I say non-blocking, it is less than or equal to. So what is this non-blocking? Equal to means immediately it will execute. When I use less than or equal to, it is assignment statement, right? So when I say assignment statement, it doesn't immediately um, execute, but then it waits. Okay, the values are actually assigned. So we will see one by one, okay, as to how it is getting executed. Now this particular slide is very important. Okay, if you understand this particular slide, then it is very easy for you to differentiate between blocking and non-blocking. Okay, so try to go through this slide. So after seeing this, do you feel blocking is better or non-blocking is better? Just have a look. Okay, so you can see one by one now. I will explain, and it will be easy for you to understand, right? So in blocking assignment, evaluation and assignment are made immediate. So there are two major steps here: evaluation, assignment. So what is evaluation? It is trying to check what is the relation between A and B. Assignment is computing the values and then assigning the values to variable X. So two important things here: evaluation and assignment. So in blocking, it is only equal to symbol. In non-blocking, it is less than or equal to. So here evaluation happens and then assignment also happens instantaneously. The first one, evaluate A or B, assign the result immediately to X. The same thing happens here. A, B, C, result is given to Y. Evaluate B and not of C, value is given to Z. So immediately it's happening step by step. But here in non-blocking, first it is checking, it's evaluating A and B. But the value is not given to X. It holds on. It holds on. It waits for end statement. Once it sees that there is an end statement, then whatever was evaluated, one by one it will start assigning. So first evaluation, all the statements evaluation is done, and then later assignment is done one after the other. But here in blocking statement, evaluation and assignment both are done together same at the same instant of time. So that is the difference between your blocking and non-blocking. Here all assignments are deferred until the right hand sides have been evaluated. So it will wait till all these equations are evaluated. Once it is evaluated, it sees an end statement, then it starts giving out values: A or B, how much is X, then A, B, C, how much is Y, then B not C, how much is Z. So all these values are assigned. So sometimes, sometimes we might need blocking statements, sometimes we might need non-blocking statements. So accordingly, we have to choose, and we have to use these kind of statements wisely in our programming. Okay, so we have one such example here. Okay, and you can see, okay, we have given initial values. A is 1 bit binary type and the value is 1. Similarly for B, C and D. Okay, the outputs after completion are A becomes 0, B becomes 0, C becomes 0 and D becomes 1. Now how is this happening? Now we have to go to the program. Module name, parameters, input is clock, output are these things, registers are A, B, C, D. Now what is the loop? Always, I told you, always is a continuous loop. Okay, always at pause edge clock. Begin. A is equal to B. Next B is equal to A. So what is happening here? Whatever is the value, the same thing is assigned, okay, to the other thing. Example. Now whatever is B's value, that is given to A. Then A value is given to B. So which means initially B had how much? 0. So that 0 comes to A. Next, in the next step, what is happening? Whatever is the value of A, that is given to B. So what was A's value here? 0. Okay, so that is given to B. So B also becomes 0. Okay, so this goes on, this goes on, and this is the final value that you get. Okay, now let us see. Now if you see your C and D, okay, so in C you had 1 and in D you had 0. Okay, so here always at process, here we are going to use non-blocking statements. So whatever is the value of D is what? 0. Okay, so it is just evaluated, it just knows that D is equal to 0, and then C's value is to be given to D. So what is C's value? 1. So that is to be given to D. So C is equal to 1 and that is given to D here. C1 value is given to D. Okay, then here D's value is given to C. Okay, so what was D's value here? 0. That is given to C. So this is the major difference between blocking. Immediately here the values change. So we will see few more examples. Okay, we will see few more examples and try and understand how this is done. Okay, so this is two main differences between your blocking and non-blocking. Variable equal to statement, variable less than or equal to. So that is important. Okay, that is very much important. Now in blocking it is similar to C code. In non-blocking the inputs are stored once the procedure is triggered. So the inputs, okay, you have option to actually save these particular values in a stack or in a memory element, and then these values are given or assigned to x, y, and z. Statements are executed in parallel. Here in blocking, the next assignment waits until the present one is finished. So immediately one after the other it happens. So the usage of blocking is used in combinational logic. Non-blocking is used in flip-flops, latches, and resistors. So examples, I can ask you as a question, where are these used? Right. So take this code as an example. Always at positive edge of the clock. So what is positive edge? The rising edge of the clock. Okay. The levels where it goes from lower level to a higher level, 0 to 1, low level to high level. Okay. So that is called a positive edge. Suppose I can, instead of positive edge, I can even use neg edge, N-E-G-E-D-G-E, neg edge. So in neg edge, what's going to happen? We are going to use the falling edge of the clock. So what is falling edge? The values which are moving from higher value to a lower value. Okay, fine. So here if you see, value of A is given to X, X value is given to Y value is given to Z. So which means all three are going to have the same value. Okay, it is just like A is equal to B is equal to C is equal to A. So all three will have the same value, B to Z. So A value is equal to Z value. So whatever was in A, that value keeps on transferring till Z. But here, that's not the case. A value, it knows what is A value, then it comes to X value, then Y value. So it will have separate. So do you see the bifurcation here? So A value is given to X, then X value is given to Y value is given to Z. So this is the difference between your non-blocking and blocking statements. Okay, fine. So yeah, so I think we will I think stop here, okay? And then we will continue in the next class. Okay, we will probably continue the next class maybe at 2 o'clock. We will see the remaining portion as to how we are going to assign these values, uh, taking the circuit as an example. Okay, I have posted this. So what I want you to do is I want you to download this and go through it. Okay, so that we will have a doubt clarification if any doubts are there. If not, then I can keep moving forward. So this one we will be studying, and then we will be even studying about how flip-flops are modeled. Okay, on important concepts we will be seeing in the next class at 2 o'clock. We will all join. Operators are also one such important thing. Okay, very much repeated question, most repeated question, marks. All these concepts we'll have to discuss. Okay, so we will join back probably in the afternoon session, uh, and we will try and discuss all these concepts in a very detailed manner. Okay, fine. Thank you.